Grishma and welcome to G tutorial. Today I am before you with the topic counting number of triangles in a given figure. Today is the day 2 of our class and I think you are clear with the topics taught in the first class, that is the aptitude section which is on problems based on trains. And today this is a topic from reasoning section. This is the easiest portion where you can score marks. So we can get to our class. This is the first type of problem. Here we are asked to find the number of triangles in a given figure. If the figure is simple like this, it is easy to count and find the number of triangles in this figure. So the number of triangles 1, 2, 3. But when we get a complex figure like this, it is very difficult to count and find the number of triangles. So we can adopt this shortcut to find the number of triangles in the given figure. Let us number it. 1, 2. So 1 plus 2. 3 is the number of triangles in this given figure. In the second question, this is the second question. Let us number it. 1, 2, 3, 4. So the sum of this 1 plus 2 plus 3 plus 4, which is 4 plus 1 5, 5 plus 5 10. This is the number of triangles in this given figure. Next, here is a larger triangle and there is a smaller triangle. First let us number the larger triangle. 1, 2, 3, 4, 5. The sum of this is 1 plus 2 plus 3 plus 4 plus 5. 10 plus 5, 15. Again let us number the smaller triangle. 1, 2, 3, 4, 5. So its sum is also 15. So 15 plus 15, which is 30. This is the number of triangles in this figure. Next figure. Let us number each of the triangles. First triangle, second triangle and third triangle. 1, 2, 1, 2, 1, 2. The number of triangles in this figure is 1 plus 2 plus 1, 3. In this one is 2 plus 1, 3. 2 plus 1, 3. Adding these 3, we will get 3 plus 3 plus 3, which is 9. So, number of triangles is 9. Next question. This question is similar to this one. We are getting a symmetric portion of the lower part. So, first let us number the top part. 1, 2, 3, 4, 5, 6. So, let us find the sum of this. This one is 15. 15 plus 6 is 21. So, the number of triangles in this figure is 21. This is a symmetric figure which is also having 6 parts. So, the sum is 21. So, 21 plus 21. We cannot stop there. There is a triangle like this. 1, 2 and 3. And this is a symmetric part of this. So, here also there is 3 triangles. Here there is 3 triangles. Here also there is 3 triangles. 1, 2, 3. So the sum is 21 plus 6, which is 48. So the number of triangles is 48. Next is this figure. Let's number the outer triangle first. 1, 2, 3, 4, 5, 6. Its sum is 21. Then this triangle. 1, 2. 2 plus 1 is 3. Then this one. 1, 2, 3, 4. Its sum is 10. So 21 plus 10, 31 plus 3, which is 34. What's the number of triangles in this figure? This one. Let us number is 1, 2, 3, 4. Its sum is 10. Here also let us number 1, 2, 3, 4, which is 10. But we cannot get triangles like this in this figure. Check, there is no symmetric portion here. So, the number of triangles is just sum of these two. 10 plus 10. 20 is the number of triangles in this figure. I think you are clear with the type 1 type of problem. Just numbering and then adding. Okay. Now we can move on to the type 2 problem. This is a type 2 problem. It is the easiest type of problem. You have to just number it 1, 2. The number of triangles is this larger number. Number of triangles is 2. Next figure. 1, 2, 3. Number of triangles formed is 3. 1, 2, 3, 4, 5. Number of triangles is just 5. Now we can move on to the third type. This is the third type of problem. Here we have to find the number of triangles embedded in the square. So the problem like this, that is, to find the number of triangles within a square, we have to number it as we have done before. 1, 2, 3, 4. Then we have to take the twice of this larger number. 4. 4 2s are 8. So the number of triangles here is 4 into 2, 8. Second problem. Just number 1, 2, 3, 4, 5, 6. 6 into 2, 12 gives the number of triangles in this figure. Then this one. Here there is an outer square and an inner square. So we have to number both. 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 2, 16 gives a number of triangles within the outer square. Then we have to find the number of triangles within the inner square. Number it. 1, 2, 3, 4, 5, 6, 7, 8. 8 2s are 16. So 16 plus 16, which is 32, gives the number of triangles in this figure. This is about the type 3 problem. Now we can move on to the type 4 type problem. This is the fourth type problem. This is an extension of the third type. Here also we are asked to find the number of triangles embedded in the given figure. This is the first figure. Let us find the number of triangles in this figure. Let us number it 1, 2, 3, 4. The number of triangles in this figure is 4 into 2, 8, as we have seen in the type 3. Similarly, here also 1, 2, 3, 4. So 4 into 2, 8 is the number of triangles. Along with that, there is a partition. Here there is 2 triangles, 1 and 2. So this is a partition between 2 squares. So in this partitions, two triangles are formed. So 8 plus 8 plus 2 gives the number of triangles. 8 plus 8 is 16. 16 plus 2, 18 is the number of triangles in this figure. Like what we had done in the type 3, we have to find the twice of the larger number. So 4 2s are 8 is the number of triangles in the given square. Similarly here also, and 2 triangles are formed at the partition. So 8 plus 8 plus 2. Next question. Here also let us number it. 1, 2, 3, 4. 4 2s are 8. 1, 2, 3, 4. 4 2s are 8. Here also 1, 2, 3, 4. 4 2s are 8. That's the number of triangles in each of the square. Then there is 1, 2 partition. So here 2 triangles are formed and here also 2 triangles are formed. So here also 2, here also 2. So the number of triangles is 8 3s are 24 plus this 2 plus 2, 4. So 28 is the number of triangles in this figure. Okay, now we can move on to the third question. Let us number it 1, 2, 3, 4. So the number of triangles in this square is 8. Here also 1, 2, 3, 4. 8 triangles. Here also 1, 2, 3, 4. 8 triangles. Now we can see how many partitions are there. Here is a partition between these two squares. So here 2 triangles are formed. Then here also there is a partition. There also 2 triangles are formed. Again there is one more triangle. This one. And we cannot find any more triangle from this. So the total number of triangles is 8. 8 plus 8 plus 8. 24 plus 1, 2 partitions. 2 plus 2, 4 plus this triangle. 1. So 29 is the total number of triangles in this figure. Next question. Here also let us number 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4. So 8, here also 8, here also 8, here also 8. 8 4s are 32 plus, like we have seen in this case, there is a triangle like this 1. Then one more triangle is there. This is 2 and then a triangle this one. So along with this there is 3 triangle more, then this partition 1, 2, 3 partitions are there. So 2 plus 2 plus 2. 2 3s are 6. So this gives the number of triangles. 41 is the number of triangles in this question. Okay, now we can move on to the next question. This is the next question. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 8, 8, 8, 8. 8 4s are 32. Then there is 1, 2, 3, 4 partitions. So in case of each partition, 2 triangles are formed. So 2 4s are 8. So 32 plus 8, which is 40. This is the number of triangles in this figure. So I think you are clear with the type of problem. This is an important type of problem. Questions from this can come for the coming NTPC exam. So give importance to this type 4 type problem. Now we can move on to the type 5 type problem. This is the next type of problem. Here a triangle is present within a triangle. The number of triangle present here is, let us number it. This is one triangle, this is second triangle, this is another triangle, and this is another triangle. So 1, 2, 3, 4 triangles are present. Along with that, this outer triangle. So 4 plus 1. 5 is the number of triangles in this figure. 1, 2, 3, 4 plus this outer triangle. So when a triangle appears within a triangle, 5 triangles are formed. So we can see the second question. There is an outer triangle. Within that, there is inner triangle. So how many triangles? 4 triangles. Then within this triangle, there is a triangle. So again 4 triangles plus this outer triangle. So 9 is the number of triangles in this figure. Number of triangle, when a triangle is present within another triangle, 4 triangles are formed. Along with that, outer triangle. So here there is 4 triangles, and when you are considering the inner 2 triangles, there is also 4 triangles plus this outer triangle. So 9. Next question. There is an outer triangle, within that an inner triangle, so 4 triangles. Within, when you are considering this triangle and this triangle, again there is 4 triangles. When we are considering this and the inner one, again 4 plus this outer triangle. So 4 3s are 12 plus 1, 13 is the number of triangles. Okay, now we can move on to the next type. This is the next type, 6th type. This is based on the type 5. Let us consider this question. This question is similar to the type 5. Let us consider if these 3 lines are not present. That is, a triangle is present within another triangle. Then how many triangles are formed? 4 plus this outer triangle, 1. 5 triangles. Then this partition is formed. So here there is 5 triangles plus partition. 1, 2 triangles there. For other partition there is also 2 triangles. When another partition is also appearing, there is 2 triangles. So 2, 2, 2, 2, 3, 2, 2 plus 2, 4, 4 plus 2, 6, 5 plus 6. So the number of triangles is 11. Okay, now we can move on to the next question. Here also, if this outer triangle, there is a triangle, within that there is another triangle, and within that there is another triangle. So we are considering only outer and inner triangle. There will be 4. Then these 2 triangles, there is 4 triangles plus this outer triangle. Then there is partition. So 2 triangles are formed here, 2 triangles here, and 2 triangles. 2 3s are 6. So 6 plus 4, 10 plus 5, 15 is the number of triangles present here. Next question. Here also, let us consider the triangles without this partition. So 4, if you are considering this and this one, again 4, again this one and this one, again 4, plus this outer triangle, plus the first partition. So 2 plus 2 plus 2, 2 plus 2 plus 2, 6, plus there is also inner partition, 2 plus 2 plus 2, 6. So this gives the number of triangles in this figure. So 6 plus 4, 10, 10 plus 10, 20 plus 5, 25 is the number of triangles present here. Okay, now we can move on to the type 7. Now we can see the type 7 type problem. Here we have to find the number of triangles in this figure. So this is one triangle, second triangle, third triangle, fourth triangle, fifth triangle. So there is 5 triangles plus. Let us consider these joints. One triangle is formed at this joint. 1. At this joint also there is a triangle. This joint also there is a triangle. So at each joint a triangle is formed. So there is 1, 2, 3, 4, 5 joints. So at each of these 5 joints a triangle is formed. So 5 plus 5. 10 is the number of triangles in this figure. Now we can move on to the next question. So here also 1, 2, 3, 4, 5, 6 triangles is present. Plus, but if you are considering joints like this, no triangle is formed, only a quadrilateral is formed. So there is no use of taking the joints. But there is 2 more triangles. This is one triangle and this is the another triangle. So 6 plus 2. 8 is the number of triangles present in this figure. Next question. This question is similar to one we have discussed before. I think it is type 4 or type 5 where we have considered a square. And the number of triangles in this figure is 1, 2, 3, 4. 4 2s are 8. So this figure, this one, this upper portion is a quadrilateral, which is an extension of a square. A square is a quadrilateral. So we can use the same concept here also. So let us number it. 1, 2, 3, 4. 4 2s are 8 is the number of triangles in the upper portion. And similarly 1, 2, 3, 4. 8 is the number of triangles in the lower portion. So the sum of this, which is 8 plus 8, 16 is the number of triangles in this figure. Now we can move on to the 8 type and the final type. This is the 8 type problem. In this 8 type problem, you have to consider a series. The series start from 1. So 1, next number is 2. 1 plus 2, 3. Then 3 plus, after 2 it is 3. So 3 plus 3, 6. After 3 it is 4. So 6 plus 4, 10. After 4 it is 5. So 10 plus 5, 15. 15 plus 6, 21. The series goes so 1, 1 plus 2, 3, 3 plus next number to 3, 3 plus 3, 6, 6 plus next number to 3 is 4, next number to 4 is 5, next number to 5 is 6. So adding that 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21. This is the series. You have to memorize this series. Now let us count the number of divisions. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the value of n is 5. Okay. Here the value of n is 1, 2, 3. 1, 2, 3. So n is equal to 3. Okay. Now what you have to do is, you have to write 5. Here n is 5 now. So 5, 4, 3, 2, 1. Then you have to consider the series. The series, 5 numbers of the series is 1, 2, 3, 4, 5. So you have to consider only this much. And write this in order. Here we are writing 5, 4, 3, 2, 1. But we are writing it in order. 1, 3, 6, 10 and 15. Okay, let us add this. 15, 35. Then take the alternate numbers. This and this. 10 plus 3 is 30. Add it with this. So 5 plus 3, 8. 3 plus 1, 4. 48 is the number of triangles present in this figure. What you have to do is, you have to count the number of partitions. 1, 2, 3, 4, 5. Here also it is 1, 2, 3. This is a symmetric figure. So 1, 2, 3, 4, 5. So the value of n is 5. Write this as such. 5, 4, 3, 2, 1. Okay. Now from the series, take the first 5 numbers. That should be written in order. This is 5, 4, 3, 2, 1, but it is 1, 3, 6, 10, 5, 15. And we will get 35. Then take the alternate numbers 10 and 3. Add it. 10 plus 3, 30. Add it to this 35. We will get 40. This is the number of triangles in this. Now we can do 4. N is equal to 3. So what you have to do first? You have to write this 3, 2, 1. Then take the first 3 of the series. 1, 3, 6. Write it in order. 1, 3, 6. Add it. 6 plus 4, 10. Then take the alternate. So add it to this. 10 plus 3, 30. 13 is the number of triangles in this figure. By adopting this method and doing, I have formed a table. So when n is equal to 3, number of triangles is 13. When n is equal to 5, the number of triangles is 48. You can either follow this method or by heart this table. So value of n is 1, the number of triangles is 1. If the value of n is the number of partitions. Okay. If n is 2, the number of triangles is 5. N is 3, it is 13. N is 4, 27, and so on. So you can adopt either this method or you can by heart this table to find the number of triangles in this figure. I hope you have understand this topic. If you are having any doubt, you can comment below. I have attached a mock test along with this video. You can try to solve it, and if you are having any doubt on that too, you can comment. You can ask me for any portions which you are needed. I will soon take class on that topic. If you are having any doubt, you can ask. Thank you.